Welcome to MST online class. In today's video, we have a problem on the board. Okay, the question says calculate the mass of potassium sulfate required to prepare 250 cubic cm of 0.20 mole per cubic dm solution. We should take the molar mass of potassium sulfate to be 174 gram per mole. Okay, now this is a very simple question. Okay, I want to provide solution to this problem, and you see. Okay, so let's quickly step into the solution. Okay, so let's get our parameters. Let's get our data. Okay, the question says calculate the mass of potassium sulfate required to prepare how many cubic cm? 250 cubic cm. Okay, that is the volume of solution required. Okay, what? 50 cubic cm of 0.20 mole per cubic dm. Now this value is standing for molar concentration or molarity. Okay, this is the molar concentration of the solution that is going to be prepared. Okay, and the molar concentration from the question is 0.20 mole per cubic dm. Okay, and the molar mass is equal to what? 174 gram per mole. Okay, so this is the molar mass. Okay, now there are some things that we need to do first before getting to the final solution. Now, if you look very well at the question, the number of moles of potassium sulfate is not given. Okay, the number of moles of potassium sulfate is not given, and of course, the main problem says you should find the mass. Okay, you should find the mass of potassium sulfate. Okay, now how do we find the number of moles of potassium sulfate, and of course, subsequently calculate the mass of what? Potassium sulfate. It's going to be very simple. Okay, so this is going to be very simple for us, but so far we have two things that we're going to do. We have two things that we're going to do. First, to find the number of moles of what? Potassium sulfate, and the mass of what? Potassium sulfate, which is actually the major problem. Okay, now we are going to use molarity formula or molar concentration formula. That is the formula used in calculating the molar concentration of a solution. Okay, from there we can find the number of moles, and then from there we can subsequently calculate the mass of what? Potassium sulfate. Okay, now molar concentration, also called molarity, is given by the equation moles, that is number of moles, divided by what? The volume. Okay, number of moles divided by the volume. Okay, now the volume is either in what? Liters or cubic dm. Okay, the volume is either in liters or cubic dm. Okay, recall that the volume given here is in cubic cm. Okay, so first we need to convert 250 cubic cm to what? Cubic dm. And how do we do that? It's going to be very simple. I recall that 1000 cubic cm is equal to what? 1 cubic dm. Okay, that is 1000 cubic cm is equal to 1 cubic dm. So 250 cubic cm will be equivalent to what? 250 divided by 1000 by 1000. Okay, by 1000. So once we divide it, we are going to find the volume in cubic dm. So we have 0.25 cubic dm as the equivalent volume of this solution. Okay, so we're done with that. Okay, so remember that I told you that we're going to use the formula molar concentration being equal to number of moles all divided by the volume in cubic dm. Okay, okay, so we're done with that. So already we have the value for molarity or the molar concentration to be 0.2 to be 0.20 mole per cubic dm, and of course the volume to be 0.25 cubic dm. Okay, so what we are looking for is the number of moles. Okay, we are looking for the number of moles of potassium sulfate. Okay, so how do we find the number of moles? It's going to be very simple. We're going to cross multiply this equation. We're going to cross multiply this equation. So by cross multiplication, number of moles will be equal to what? Number of moles will be equal to molarity multiplied by what? Volume. Okay, molarity times volume, or the molar concentration times volume. So the molarity from the question is 0.20 mole per cubic dm. Okay, and the volume is what? 0.25 cubic dm. So if you check this out using our calculators, we are going to have 0.05 moles. Okay, so basically we have calculated the number of moles of potassium sulfate. Okay, and we have found that the number of moles is equal to what? 0.05 mole. Okay, as simple as that. Okay, but remember that the question says we should calculate the mass of potassium sulfate required. Okay, we should calculate the mass. Okay, so this is not the major problem. Okay, it is just a pathway to providing solution to the major problem, which says we should find the mass. Okay, now how do we find the mass? In our previous videos, I had established that number of mole was equal to what? Mass divided by the what? Molar mass. Okay, so basically we're going to use this to find the mass. Okay, okay, so this is going to be very simple for us. Okay, already we have the value for number of moles, of course the value for the molar mass, which from the question is 174 gram per mole. Okay, so this is going to be very simple. How do we find the mass? We still want to cross multiply this equation. So once we cross multiply our mass, we're finding mass. Okay, this is what we're looking for. Okay, so once we cross multiply our mass will be equal to what? Number of moles multiplied by what? The molar mass. And number of moles, we have calculated it to be 0.05 mole. And the molar mass is what? 174 gram per mole. So if you check this out using our calculators, 0.05 multiplied by 170, we're going to have 8.70 gram. Okay, .70 gram, and that is the final answer. Okay, so basically we have calculated the mass of potassium sulfate required to prepare 250 cubic cm of 0.20 mole per cubic dm solution. Okay, so as simple as that. And this is a very tricky chemistry problem. Okay, that we have demystified at MST online class. Okay, if you're interested in this kind of videos, don't forget to like and share. Subscribe to my YouTube channel, MST online class. Follow me on TikTok, MST online class, and of course on Facebook, MST online class and MST Kumade. Thank you for watching, and God bless you. See you in my subsequent videos. Bye.